Hey, welcome back. I have the slotting head on the milling machine, and I was thinking that might be a good opportunity to show you some best practices with slotting head on a milling machine. Granted, not many people will have a Deckel FP1 with a large rotary table and a slotting head, but the basic principles also apply when you do slotting with the quill of a milling machine, just manually punching down the tool like I have shown in the past, or if you have a Bridgeport with a slotting head, or if you're using a shaper to cut keyways. Granted, I have used the shaper in the past for doing keyways too, but it's a little bit annoying to set up because you're fighting gravity all the time. But it's absolutely doable, and it's a very well suited machine for it. But in my case, since I have the slotting head and I don't have a shaper anymore, that's always fun to drag it out. So let's look at the setup and how it's set up. Look at all this real estate. So that's a large Deckel rotary table, of course. And today I have the rigid table and the rotary table on the milling machine because I need the rigid table for something else. And I figured instead of switching back to the indexing head, I'm using the rotary table. This thing doesn't get too much use anyway, so great opportunity to play with it. And it turns out this is incredibly stiff compared to the indexing head. The indexing head is, in all honesty, very close to a wet noodle, but the rigid table with the rotary table on top of it is more like old bread. A few basics when you, let's take a workpiece. When you have a workpiece and you want to cut a keyway in it, you want the keyway to be on center line or centered to the center line. Otherwise it doesn't really fit very well, and the way the load is transferred from the key to the shaft and to the keyway in the shaft, if you manage to assemble it with a slightly off-center keyway, is not great. You're creating very weird stress risers that way. So you want to do this properly. There are different ways of doing it. I have shown this in the past and I have done it in the past, but I'm not really a big fan of it because it's very easy to mess up. In the past, I just eyeballed the tool and took scratch passes until I got two contact lines between the tool and the part. And when those two contact lines looked even, I figured that it would be on center. Maybe not scratch the bore here, but you get the idea. Just eyeball it on center line. It's very easy to get that wrong. So then when I looked at real vertical slotting machines, I noticed that all of them have a rotary table, and I never could really figure out why, apart from making multi-position splines, of course. But the other reason is because the rotary table makes you centering up your tool bit very easy. And that opinion was also reinforced when I read through the manual of the Deckel mill, because that's exactly what they recommend to line up the tool bit. So the theory is that you have your workpiece always on a rotary axis when you do slotting operations, because with the rotary axis you also have a way to sweep the tool that's held in the slotting head. That's kind of the whole point of this exercise. So you align the rotary table to be on center with your slotting tool, and then you align your workpiece to be on center line with the rotary table. It's that easy. And to sweep the tool on center line, you just need an indicator, dial test indicator in a stand with the pointer or the needle facing like this. So when you rotate the rotary table, I disengage the worm so I can just sweep it by hand. So the needle strikes an arc. The radius of this arc does not matter at all. To sweep one side of the tool, you just come in. Well, let's do this on the end of the tool. You just come in, make contact with the dial test indicator, and you rotate the table back and forth, and you find the high spot, just like this. It's in this position, Then you crank your table to a convenient number like 0. And in this position, you zero out your DRO. Then you retract your tool and you rotate this entire deal 180 degrees. And you move back in towards the tool. And you do the same sweeping on this side, finding the high point. That's here. Then you crank to 0. Like this. The DRO shows now a funny number in X. We take that number, split it in half, and when we crank to 0, we should be exactly on center line with the rotary table. Just like this. To double check what we just did, I moved the x-axis to center line, and I brought in the dial test indicator to touch the tool in front here. Keep in mind, you cannot move the y-axis or the z-axis when doing this, when you do side-to-side sweeping, because the tool has a back taper in 2 directions, and that would alter your dimensions quite significant. So we have 0 on this side. I swing over 180 degrees. We're going over the edge. That's why it rises so far. Now it drops down. And we are within, well, that's within 10 microns. That's perfectly fine for this application. So yeah, that's centering up the tool to the rotary axis of the slotting head. In my opinion, the best method, the most reliable, and you get a qualifiable reading. It's not like eyeballing. The part is up on 2 blocks now. To raise it up off the table and holding it down with 2 strap clamps. And it's on, I centered it pretty much. Just by bumping it around with a copper drift until it ran through. And now we can do our slotting. Get the rotary table back on 0 degrees. Lock it, and we're good to go. Double checking that we clear all the clamping hardware. This looks super close, but there's at least 3 millimeters in both orientations left, so not going to worry about it. Cutting tool clears on the underside of the part, and the stroke is long enough so we clear the top of the tool and have time to advance our tool into the cut. So everything's fine. Now we just need to pick up, to touch off the tool to zero out our DRO in this direction. I just realized that this will get extremely close once I start to move this way. So I'm going to move both of these clamps a little bit just to be on the safe side. Crashes with the slotting head have to be very jarring, so it's better not. And now we just let it move up and down and feed in slowly, always feeding with the tool in the upper position. Cutting oil. Last double check. I don't use the slotting head so often, so I prefer to double and triple check. Slow speed, that's 100 RPM, that's 40 up and down strokes per minute. This is going extremely well. The slotting head is a super civilized tool. And that's it. That's keyway cutting with the slotting head. It's super no drama. So I built the gauge block stack for the lower end of tolerance. I like to keep keyways, especially in a motion application, with this is a timing belt. I guess this will drive some kind of an axis. I like to keep the keyway very tight, otherwise relative motion between the shaft and the keyway, or between the key and the part mounted, can cause inaccuracy and also wear out the keyway. By the way, because it sounds like keyway or keyway, it's a keyway. Keyway is a funny bird. So I also have to do 2 of these smaller timing belt gears, and these were diameter-wise too small to clamp them down directly on the table, so I still had one of those self-centering 4-jaw chucks that I have no clue where I got this from. I think I bought it with a lot of tools quite some time ago, but it comes in handy to have a loose chuck that you can use for things like this. Clamped down, centered it up, holding the timing belt gear in the chuck, supported with parallel so it doesn't get pushed through. And in this case, I also had to change the tool. This is a 3mm wide slotting tool. Fairly long slotting tool, that is. And I'm cutting towards the column of the machine. That's, by the way, the recommended direction, because you create less overhang, especially on large bores, from the column of the machine that way. I wouldn't really call this a job, but another tiny project done. Completely unrelated, but well, I'm already here. So I needed a mill vise, a bog standard mill vise that I can put on the rigid table or on the rotary table to do normal, non-super tight precision mill work. I used to have the Gerardi modular vices. I sold those when I sold the benchtop milling machine, but it turns out it kind of sucks to not have a full-sized mill vise when you have to do things like, well, plates with holes and slots milled into them. And having the indexing head on the milling machine and using the toolmaker vise on it is all fine and good if you do mostly high precision work with small amounts of machining on them, removing small amounts of material. But from time to time, even I need to use bigger tools like face mills, shell mills, large end mills, and of course face mill that's not set up currently because I have stolen the arbor for something else. And that's a situation when the indexing head comes very quickly to a very abrupt end. It lacks, well, it doesn't lack stiffness, it's just not as stiff as the full rigid table of the mill. You can imagine that this is basically a large angle plate that's T-slotted on top, and this is substantially stiffer than the indexing head. There is no no doubt about it. Same goes, by the way, for the tilting, swiveling, and rotating universal table. That's also kind of a a semi-wet noodle. It's perfectly fine for what it's made for, but you have to remove material in larger amounts or have processes that create a lot of cutting force. It's not the right tool to use. So, and I don't have a mill vise that fits on the rigid table. So I was looking. I used to have, as I mentioned, I used to have the Girardi vises, picture shown here. They are fine. Many people make good parts with them, but I had some, I didn't like them too much. So I looked further on. In the past, I have used a lot of toggle locked vises from Hilma and Arno, or hydraulic vises. Those are very common here in Europe, or in Germany at least. But I'm also not the biggest fan of them. Also, they are horrendous expensive. So I looked over the ocean, and well, it appears that the Kurt vises are fairly common in the US, and well, it's good enough for some of the machinists that I respect a lot. So it's probably more than fine enough for what I do here. And Kurt doesn't really sell directly here in Germany, but Haas tooling is sold. They have an online shop. You can just go there, and it's usually all on sale. And it ships from Belgium most of the time. And they sell Kurt vises under the Haas branding. So it is a Kurt vise, but it has this hideous red color scheme, of course. But red makes it 50% faster, if I remember correctly. And, well, I just unpacked it, and it's a nice vise, I have to say. The handle is not, well, it's a vise handle. It's fine. But everything else is really, really nice. It's well made. The grind is very, very serviceable, nice. The only thing that's a bit crude is this little vise stop up here that goes into the slot of the jaw. But apart from that, everything else looks really good. I will quickly throw this on the surface plate and just run an indicator over it to see if it's ground parallel. Let's get the moving jaw off so we can indicate it nicely. So you undo this jaw here, and you pop the moving jaw, and now I can measure the parallelism of the vise. Over at the surface plate, I stoned the underside of the vise just to be sure. A 2-micron indicator here, already zeroed it on the surface of this rail where the moving jaw runs on, and also where the work rests on if you put it on parallels. And we got a 0 here, and when I move out here, it stays, it drops to -2 micron. Let's move over to the other side without bumping into anything. We start at 0. 0 drops to -4, -5. Let's see if I have a pen. It's -5 here. It's -4 here. And that's 0 here. Keep in mind, this could also be my surface plate. This is only a grade 0 surface plate that can be, or that is, up to, in my case, up to 3.5 micron out of flat. Also, the surface gauge I'm using here is not exactly the ideal tool to run a sub 10 micron indicator in at 0. Here it's -2. Yeah, that's well within 5 micron from here to here to here to here. I'm fine with that. Was that now a review of the vise? Oh no, absolutely not. I had this thing in the shop for like half an hour. I ran an indicator along it and I cranked it open and shut once. I will tell you in maybe 2 years what I think about it. I was also thinking about doing a retrospective on the Deckel mill that I had for 3 years now in the shop and the Weiler lathe that I had for 2 years in the shop now. Very heavily considering doing that. Discussion about the machines I replaced and if the industrial machines were a good replacement for them or not. Maybe that's interesting. I have some thoughts about it. And if those machines that I have chosen were the right choice. So, back to keyway slotting. slight tangent here. Close-up of the chips from the 5mm slotting tool. I think they're quite neat chips. That's all I wanted to show you. Here are the finished timing belt gears with all the keyways cut into it. Quick look at the tools. 5mm and 3mm slotting tool started their life as 8mm diameter round high-speed steel. I made an adapter to hold these tools in the slotting head. Slotting head takes like 16 or 20mm square shanked tooling, and for light duty applications like I have, that's a little bit massive. Forging and grinding down a 20mm square high-speed steel blank is on the annoying side. So I just grind them out of a piece of high-speed steel on the surface grinder with a spin fixture, or now as I again have one on the D-bit grinder. And the angles are quite simple. Let's do a quick sketch of these tools. So if we look at the tool in a side view, we have the shank. We have a relieved section here. This is just straight down. We have a transitioning angle here. Forward-facing rake. We have a line here. I'll explain that in a second. Symmetry line, of course, for the shank, because we are not monsters. So this angle here, well, let's draw it like this. You want a few degrees here, like 3 to 5 degrees. You want a little bit of positive rake here on front, like, again, 3. You will often see 7 degrees in the literature. I usually go for 5 degrees. This area here needs to be relieved a little bit. It's thinner than the cutting end of the tool. This is thickness minus 0.2, with thickness being the actual cutting width. And this area of the tool here, if you can, you want it to be a little bit thinner on this end, so you grind it like a 1 degree back taper and also a 1 degree taper to the top. So it gets thinner up here and thinner to the back. It's very helpful. Or you don't do this, but you relieve it to down here and just leave a tiny section straight. And this is enough so the tool doesn't rub like crazy when you cut your keyway. So that's all the magic behind these slotting tools. And there you have it. Bunch of keyways cut on the FP1 using the slotting head. Hope you learned something. Thank you all for watching, and I'll be back.